In this video, we're going to go over 3 different application problems for linear equations. There are some steps that are provided from the OpenStax textbook that you can look at, but we're just going to jump into this first example here. We want to find a linear equation to solve for the following unknown quantities. One number exceeds another by 17. And their sum is 31. Find the two numbers. I actually want to first think about the sum piece. That makes a little more sense to me. So I know if I add two different numbers, their sum is 31. I also know one of those numbers is bigger than the other, exceeds means bigger than the other by 17. I'm going to assign a variable to these pieces here. All I'm going to say then is, okay, well, x plus y equals 31. And I know that x must be equal to y plus 17. It doesn't matter which way we find the exceeds. If you wanted to say y equals x plus 17, we would just kind of have the opposite answers for x and y if you did it that way. Since I know x is equal to this quantity with y, I'm going to plug that in for x here. That gives me y plus 17 in place of x plus y equals 31. Since I'm adding here, I can drop these parentheses without any worry and get that 2y plus 17 gives me 31 when I combine like terms. And then I'm going to solve this like a linear equation, subtracting 17 on both sides. I end up with 14 on the right-hand side, dividing by 2, and I get that y must be 7. If y is 7, then I can plug back in here to solve for x. X must then be 24. Let's look at example number 2. Set up a linear equation to solve this real-world application. There are 2 cell phone companies that offer different packages. A has just a monthly service fee of $34 and then charges 5 cents a minute for each talk time. Company B charges a monthly service of $40 and then less per talk time. So let's again write this out with symbols. Maybe I just say A is equal to 34 plus 0.05 times the number of minutes that you talk. Company B charges 40 and then 4 cents for every minute that you talk. Again, let's put this in x's and y's, where y, or maybe we call it C for charge instead of x's and y's. Let's maybe call it a little different number or different variables. And let's maybe call this T for time. And then this charge just like before, I can then plug in one of these in for the variable in the other one. So I get 40 plus 0.04t equals 34 plus 0.05t. I now have the same type of pieces of my equation, of my linear equations on both sides. So let's combine like terms. I'm going to choose to do this by keeping t positive. So I'm going to subtract 0.04 t on both sides. And then I'm going to subtract 34 on both sides. That will get rid of my 0.04 t here and get rid of my 34 here. I then have 6 equals 0.01 t. And then I divide by 0.01. You can use a calculator if you need to, but 0.01 is 1/100th. And so if I divide by 1/100th, that's the same as multiplying by 100. And so our talk time would have to be 600 minutes in order for these two plans to be equal to each other. Now, I believe the example just wanted us to be setting this up. There wasn't a question of where to go from here, but that's where the intersection point between those two company charges would be. And so if $34 is a little bit less, right, then between 0 and 600, company A would be a good one to look at. But if you're going to be talking a lot, so if you're going to have over 600 minutes of talk time, then you might want to go with company B. Even though they charge a little bit more, the less talk time the less charge per minute means that that's a better plan for over 600 minutes. All right, let's look at one more problem. The perimeter of the rectangle on this patio is 54 feet. The length is 3 feet greater than the width. What are the dimensions of the patio? Well, perimeter is twice the length plus twice the width when we have a rectangle. We are also given that the length is 3 feet greater than the width, and you can see that in the diagram that was provided in this problem as well. I'm going to go ahead and let my perimeter be equal to 54. And just like we've solved all these other problems, I'm going to substitute in for the problem, or the variable, excuse me, that I know in the original equation that I was given, or that I was writing. So that gives me 2 times w plus 3 plus 2w must be equal to 54. 2w plus 6 plus 2w equals 54. I got that by distributing my 2. 4w plus 6 equals 54. I'm then going to subtract 6 on both sides to isolate my variable. I get 48, and then divide by 4. So the width has to be 12. If my width is 12, I know my length has to be 3 more than that. So my length must be 15.